Okay, an asymptote. An asymptote is a line that a graph approaches but never touches or crosses. Asymptotes guide the end behavior of a function. So that means as the function goes out to negative and positive infinity on the x and on the y. So it's that imaginary stuff clear out here and here, here, and there. So yesterday we actually kind of talked about how you knew where the asymptote was, but you didn't know we were doing that. If you look at the graph here, we put them when we graph things, we put dotted lines, like dashed lines, to show that imaginary line so you can see it to help you guide yourself. So yesterday we actually graphed y equals 1 over x, didn't we? And it looks similar to this. Ours was probably prettier, wasn't it?
Oh, yes.
So this is the parent function of the reciprocal function right here. So as x approaches infinity, that's negative infinity and positive infinity, what are the y's doing? Getting closer and closer to 0, aren't they?
Yeah.
Okay, but they're never going to be 0 because anything I put under 1, is that going to give you 0? No.
0.
Well, can we divide by 0?
Yeah. No.
No, because like I have this pin right here, right? And I'm going to divide it 0 ways.
No one gets a pen.
No, I still have what?
No one gets a
One.
pen.
I still have a pin, yes?
No way.
And if it was divided 0 ways, it would have to be gone. And until I learn how to do magic, it's still here. Correct?
Throw it away.
So we cannot divide anything by 0. Now, can we divide 0? I have no candy. How much do you all get? None. So you can divide 0, but you cannot divide by 0 because you still have an object. Everyone's like, well, you didn't divide it, so you divided by 0. No, I divided by 1 because I still have 1. So there's nothing I can put into this equation that would give me 0. So I have a horizontal asymptote. That's a vertical line, sorry. A vertical asymptote because I can't put 0 in here. I have a horizontal asymptote at 0 because nothing I put in for x will give me what? 0. Just like vertical lines, if I would give you an equation of a vertical line, it would be x equals, wouldn't it? Mm-hmm. And if I have an equation of a horizontal line, it would be y equals. So your horizontal asymptote is based off of your y, and your vertical is based off your x. Or your domain for your vertical and your range for your horizontal. So if I were to ask you the domain and range, the domain, if we put in set notation, would be negative infinity, because I'm coming from this way, right? Mm-hmm. And I go to everything and stop on the zeros at where? At x is at 0, right? So negative infinity to 0. And it would not be a bracket, be a parenthesis because it doesn't include 0. Union, so you put a U. And then you pick back up at 0 and go to where? Positive infinity. And we have parentheses on both ends because 0 is not included, right? Our range feel like this is really messy. Our range then is our outputs, right? Our y's. Well, you always go bottom to top, right? Is it going to negative infinity? Is it?
Yeah.
Yeah, so it's negative infinity. And then I'm coming up, and what am I not getting to?
0.
0. But am I approaching it? Yeah. Am I ever going to get there? No. So negative infinity to 0. Then I pick back up at where? 0 and go where? Positive infinity. I don't know why I put a U there. So you're going to be asked to do some domains and ranges. So if you know if you know what my asymptotes are, is it going to help me with my domain and range? Yes. Okay, again, domain is your vertical asymptote. Oops. Can I just put abbreviate? Okay. Your domain, the vertical asymptote, is not included. Because 0 is my vertical asymptote, right? And in your range, your what asymptote is not included? Horizontal. Now, this will change, but not for you guys. And not evidently is non, I was going to put N-O-N-T. Non-it? I don't know. Now, next year, remember I told you we're going to do this next year in pre-calc, and then the year after that in calculus. When we get there, we'll have some more exclusions to the horizontal asymptote. I've talked about it only affects end behavior. So that is behavior out here and behavior out here on the horizontal. But in here, we could have some different things going on. Okay? And I already went the last paragraph. Anyone have any questions about what we went over?
No.
Okay.
We're done.
No, we got to apply it. Don't you want to, do an example?
I mean, I guess.
Oliver, you good?
Yeah.
Okay. So we need to graph y equals 10 over x. What is the domain, the range, the asymptotes of the function? Now, we're not always going to find things in the order that they say. I am probably, actually, no, not probably. I am. I'm also going to ask you to find the x-intercepts and the y-intercepts. Have we found those things on other graphs? Mm-hmm. Yes. Do we find them the same way on every kind of graph? Yes, we do. It's just different equations, okay? Because an x-intercept is where y equals 0, and a y-intercept is where what? X equals 0. So we know that. Trying to, there we go. Not have a big old wide x-axis and y-axis. So I'm going to start by just giving myself an x and a y-axis. Okay, so x-int, I always start with the x-intercept. The x-intercept is where it crosses the x-axis, yes? And the y is always 0 there, isn't it? So you set the equation equal to 0. So we'd have 0 equals 10 over x. So if I were to solve this equation, Cooper, Focus. I would multiply by x on both sides, correct? Well, what's x times 0?
0.
0. So does 0 equal 10? Or can it equal 10 when there's no variable? No. So it doesn't equal, so there is none. Okay, y-intercept. Well, an x-intercept, you set the y equal to 0. A y-intercept, you set the what? X equal to 0. So you have y equals 10 divided by 0. Well, we've already discussed this. Can I divide by 0?
No.
No. So there is none. Because this answer would be undefined, right? Okay. So on some of these, are we going to have none and none? Yes. But I want you practicing doing it so you don't forget. Got it? Okay. So we can't do domain and range very easily until we know asymptotes, because I said they were based off the asymptotes, right? Okay, so vertical asymptote, and I just say VA. So vertical asymptotes are exclusions in the x-axis. So what x cannot be. And we have a fraction. The only thing that the denominator cannot be is what? 0. It's the only thing. So all you do is set the denominator equal to 0 and you find the vertical asymptote. So what is the denominator?
0.
No, what is the denominator right now?
X.
X. So x equals 0. So the vertical asymptote is at where?
0.
X equals 0. Got it? Now, the reason why I say that, because could I have 10 over x plus 4? Yes. And you would set x plus 4 equal to 0, and you would subtract 4, and so your vertical asymptote would be at negative 4. So it won't always be 0. I think today it kind of is, but. Okay, so it says x equals 0. It's vertical, so that is a vertical line, yes?
Yes.
Well, x equals 0 at what vertical line on every single graph? Where is x 0 at? It's on the y-axis, yes? So how we show that is just a slanted dashed line. And the reason why it's slanted is because the y-axis is straight, yes? And if you went horizontal, they would look like you're doing tick marks, wouldn't it? And they're not the tick marks. Okay, horizontal asymptote. Well, this is where it gets kind of like abstract. We have to look at this equation. Oh, horizontal, I guess it would be HA, right? When is that graph, like, what number will it never be?
0.
0. Why?
I don't know. I just said 0.
Is there any number that you can plug into 10 over x and get 0?
No.
No. Because the only way it could become 0 is if the denominator is 0, and can the denominator be 0?
No.
No. So it's going to be y equals 0. Yes? Okay, so we're going to put another what? Slanted dash line. Now, our asymptotes are the same as before, aren't they? But before we had 1 over x, didn't we?
Yeah.
How is 1 over x going to be different than 10 over x? What do you think? Well, if I put 1 over x and I plug 1 in for x, what do I get? 1. But if I put 1 in 10 over x, what do I get? I get 10. Is that going to look a lot different? Yeah. Okay, so let's do our domain because I think we can do it. What do we have to look at for the domain? The vertical. Okay? So in your brain, picture walking down a sidewalk. The x-axis is a sidewalk, okay? Got it? Asymptotes are like fences. Can you walk through a fence? No. Okay. So I'm me, running down, whistling, singing away, walking down this sidewalk, and what happens? A fence. So I gotta stop. I gotta stop, right?
Just do Marshawn Lynch and run through it.
No, I can't. So my domain is gonna start where? Where did I start?
Negative.
Negative infinity. And what caused me an issue?
Zero.
The 0. So what do I put over here? A bracket or a parenthesis? Parenthesis, why? Not included. And then I put a U because there's another piece, right?
Yes.
So I got to do something to get over this fence. I get over the fence and I end up where?
At 0.
At 0, but not on it, right? So I use a parenthesis. And then I can go on to where?
Positive infinity.
Positive infinity. And range, I have struggled all of my teaching career how to explain range. And so I'm going to explain it this way. Let's graph it and then look at our picture. How about that? Okay? So we don't really have any information. Like I don't have an H or a K or anything. I haven't told you any of that stuff, have I? So I've got to figure that out. Well, if I don't have any information, how did we graph it yesterday? What did we do? We made a what? When we made our graph, how did we do it? We made an XY chart. So is that something I probably should make? Yeah? Okay. So X, Y. Because until I get a feel, like I could graph this right now, but you can't, right? So I'm going to divide 10 by numbers. So what kind of numbers do I want to put in there for X? Numbers that go into what? 10. I don't want to put 3.
1, 5, 2. 2, 1, 2, 5.
Okay, so we're going to go -5, -2, -1. We're going to put 0, but what's the answer at 0?
0.
No.
What?
What happens when I put 0 in this? It's undefined. Why is it undefined? Because you can't divide by 0. Okay, so I'm plugging it into this equation, right? So 10 divided by -5. -2. 10 divided by -2.
-5.
And then
-10.
10, 5,
2.
and 2. Okay? So I probably need to make some tick marks, huh? Probably should have used green when I had blue, but oh well.
Or to make new tick marks?
Well, the other tick marks, they aren't tick marks. They're what?
Oh, approximation.
They're asymptotes, right?
Or as it does an approximation.
So usually I put my tick marks before I put my asymptotes, but okay, so when it's -5, 1, 2, 3, 4, 5, it is what? -2? I gotta make the point a little bigger.
The dot goes up to -5.
Well, when x is -5, y is -2.
Oh.
And then when x is -2, y is what?
-5.
-5. So is this an exact science? No. Okay. When I'm -1, I'm negative what? 10. I'm just going to put a dot down there. Can you kind of see the curve, what it's going to do? Yeah. Okay. And then when I go to 1, it's 10. And when I go to 2, it's 5. And when I go to 1, nope, 5. It's 2. And so, like, what if I went to, like, -10? If I went to -10, what would the answer be? 10 over -10 would be what? -1. So I could go, like, clear out here. What if I went to 20? -20. What would it be? -1/2. It would get closer and closer to what? 0?
Yeah.
And when I go to 10, it goes to 1. And if I went to 20, it'd be 1/2. If I went to 40, it'd be a 1/4. If I went to 1,000, it'd be 1/1000th. But is it ever 0?
No.
No. Okay. So do you see your curve there? Yeah? And so now I draw my curve. Are they always going to have this same curve until I start doing more with it?
Yeah.
Yes. So, could you see, like, maybe if I added an H or a K? Could you see it could do something? So, that would be, I think it would be like, the X is in the denominator, right? So that means it would have to be X minus H, wouldn't it? Wouldn't it have to be down there? And so what would go in the numerator? What other variables did we have? We had K, but that wouldn't go in the numerator. What would happen to it? It'd be over here, wouldn't it? So we had an H, a K, and there was one other variable we had. What was in the front?
A.
A. Did A tell me, like, the rate of change? Like how fast it was changing or how slow it was changing?
Yeah.
Do you think 10 has the same effect on that?
Yeah.
Yeah. Because when we had 1, wasn't my graph more like this? And so when we had 10, it changes quicker, doesn't it? So it kind of pulls it away from the x-axis. So if I go like a half, what do you think it's going to do? It's going to get closer to the, it's going to look like it's almost doing an L, isn't it? Is it ever going to do an L? Like a right? No. But is it going to look like it, maybe?
Right.
Yeah. But isn't that weird how completely different, but when I did quadratic, I did A x minus h plus k squared. And when I did absolute value, I did y equals a x minus h plus k. Did I promise you you'd always have an h, a k, and an a?
Mm-hmm.
And did I promise you they will always do the same thing?
Mm-hmm.
And have they done that? Okay.
Range.
Oh, we need range. Thank you. I got all this extra writing.
I was like,
Okay, so range, we got to look at the picture, right? So what y values are not included?
0.
0. It's the only one that's not included, isn't it? Because of my horizontal asymptote. So it starts at negative infinity and goes to 0, picks up at 0 and goes to where?
Positive. Is that it? Do you want to see that a over x minus h?
Not yet. We don't have to. But we could. Like, right here I have 10 over, what's my k? And 10 over x. What's in 10 over x, what's my k? What's out here? Anything? So it's what? 0. What's my h? Is there anything? So it's what? 0, 0, 0. See it?
All connected.
Is my K going to give me, my K goes left and right, right? So what's it going to change, horizontal or vertical? Vertical. H, no, sorry, I said that wrong. You guys didn't catch me. K goes up or down. Yes? K goes up and down. So is it going to do horizontal or vertical?
Vertical. Oh, I said horizontal.
It is horizontal.
Why? How if it goes up and down?
Because what's going up and down? The horizontal asymptote.
Oh yeah. Oh yeah.
Okay. What is H going to do?
Go.
It moves it left or right, so it's going to be moving the vertical asymptote.
That's weird.
It is. So if I know the parent function, the 0, 0, does that help me with the H and the K? Yeah. So if you don't have an H and a K, you don't need to use it. If you have an H and a K, should you use it to your advantage? Yes. So if you can remember those things, will it help you out? Oh, look at that. How silly. What just happened? I have an H and a K.
And an
Well, A is 1.
A. Well, yeah, but it's still an A.
It is, yeah, you always have an A, because if you don't, you have 0.
You should change the numbers to x minus 3 or x minus 5 and then plus 3.
Why?
Because we should.
Why?
Because it's a homework problem.
No. Okay, so how do you guys want to approach this? It says, what are the asymptotes, domain and range? And it says graph, so I probably should do my x and my y-intercept, right? And because if I move this up or down or left or right, I'm going to have one of those things, aren't I?
Yeah.
Because it's going to cross. So I always personally like to do x, y, vertical, horizontal graph. Domain range. That's how I like to do it. Does that sound good? Okay. So x-intercept. How do I find an x-intercept?
Set y equal to 0.
Set y equal to 0. So 0 equals 1 over x minus 3 plus 2. Okay, so I got to solve it for x. How would I do that?
You would subtract 2
Subtract 2.
and then you're going to do the reciprocal.
Well, yeah, cross multiply. Multiply by the... So I have to multiply negative 2 by x minus 3. Right? So that gives me negative 2x plus 6 equals 1.
Do you add the minus 1 over?
Mm-mm. What are you solving for?
X.
So you got to move the what?
The negative 2.
No,
the 6.
the 6. So subtract 6. So negative 2x equals negative 5.
Yeah.
And then divide by negative 2. So x equals 5 over 2. So that's what? 5 over 2 is 3.5, right? No, 2.5?
2.5, yeah.
Yeah. So it's not a perfect number, but could I find it? Yeah. So I have 5 over 2, comma 0 would be my x-intercept. Now, why do I have an x-intercept? Because I have an h and a k. If I didn't have an h and a k, would it allow me to have an x-intercept? No. And it's actually going to be my horizontal, my up and down. So if I have a k, is it going to allow me to have an x-intercept? Yes, because it's going to move that asymptote up or down. If I have a k, it's going to allow me to have a what? Y-intercept. Okay, can I erase my work?
Yeah.
Okay. Okay, so y-intercept, how do I find a y-intercept?
Set x equals 0.
X equals to 0. It's always easier to find a y-intercept, I think. So y equals 1 over 0 minus 3 plus 2. So that gives me negative 1/3 plus 2, but I have to get common denominators, so that is going to be what?
6 over 2.
6 over 2? Or 6 over 3? So that's going to be
-5.
not negative. I wanted to do it too. 5 over 3. So not pretty again, but x was 0, correct? And we got 5/3. Not pretty, but we know it's almost 2, don't we? How do I know it's almost 2?
Because 5 is close to 6. And
5 is close to 6, and 6 over 3 would be 2. This all helps us with our number sense and being able to visualize and put things in place. Okay? So now what's next?
Domain and range.
Domain and range. How about vertical asymptote? Yeah? So vertical asymptote. And I don't know why I've put an X. We abbreviate it what? B dot A. Okay, so vertical asymptote. The 2 is not going to affect my vertical asymptote, is it? No, it's not. Because 2 is 2. Nothing is ever going to change it, is it? But when I have a fraction, I have to think about things. What can't I do with the fraction? What can't happen no matter what fraction I have? What's wrong to do? Divide by what? 0. So I have to find out where this denominator is equal to what? 0. So I put x minus 3 equals 0. So x would be what? 3. So x equals 3 is my vertical asymptote. That is what I cannot be. Because if I put in a 3, what is my denominator going to be then? 0. And can I divide by 0? No. So 1, 2, 3. At 3, I have a vertical asymptote. So I'm going to put a what? Dotted line at 3. It's much nicer to look at when they're not on the X and Y axis, I think. Okay?
It died. Or it ran out of water. Oh, it probably ran out of water.
Okay. So now I got vertical asymptote. I need to find the horizontal. Well, what variable did we say affected the horizontal? H or K?
Okay.
K. The up or down, right?
So
So K equals what?
2.
2. And the horizontal asymptote was at 0, right? So everything moved up, what?
2.
2. So it's now where? At what?
2.
2. So horizontal lines are Y equals 2.
Oh.
So at Y equals 2, I need to make a horizontal asymptote. So the parent function, I'm going to draw it in. You guys don't. Just look up here. The parent function was like this, correct?
Yeah.
Oops. And it's moved. Like it moved over and up. It didn't. How would I flip it? How would it go from this to this? What would a negative on the top? It could be on the bottom too, right?
Right.
But if a negative was there, it would flip quadrants, wouldn't it? But we don't have that. So we've taken this shape and moved. So I should be here and here. Am I going to have an X and a Y intercept then? Yes. Did we find an X and Y intercept? Yes. We said that 2/5 was 2.5. Well, yeah, 5 sorry. Is that right here? Can you see my purple?
Yeah.
Is that right there?
Where's that? 2.5. Oh.
You see it? Is that 2.5? Is that in that space we said it should be?
Yes.
Okay. And we got 5/3, which is
Close to 2.
close to 2, but is it 2?
No.
No.
It's like
So it's right there. my dot's kind of big. Is that in my space?
Yeah.
Yes. So my line, my graph is going to be over here. Yes?
Yeah.
And over I didn't draw very good. I made too sharp. That should be a nice curve, shouldn't it?
Yeah.
For some reason I don't want to do a nice curve right now. So that's what my graph should look like, isn't it? Did I have to make a table?
Nope.
Nope. I should put some arrows, huh? I always put them like on the right hand side of everything because it comes from the left to the right. So now we need to do what two things? Domain and range. Okay, well, I haven't done anything funky with the middle, right? I told you that someday we will, but not anytime soon for you guys. So I don't need to worry about that. So where do I get my domain from? Which asymptote? Vertical. Okay, guys, domain are x's, yes? Vertical are what? X's. Get it? Horizontal are y's, so they affect the range. Okay, so always start where? Negative infinity. Walking along, where am I going to hit that fence? We're going to hit that vertical fence. At 3. Am I going to include 3?
No.
Nope. Union. Where am I going to pick up at?
3.
And go to
Positive.
positive infinity. You should not shut your book. Okay, range. Where do I always start? Negative infinity. Only on these, right? And I'm going to go and never get to where?
2.
2.
And then you do your little union.
Union. Pick up at 2. Positive infinity. Please don't shut your stuff yet. We're not going to have time for another one, but I need to look at the H and the K.
Hey.
Okay.